The standard way we use artificial intelligence is strictly linear. You type a complex question into a prompt box, hit enter, and wait for the machine to generate a single answer. If that answer isn't perfect, you refine your query and wait again. This loop of asking, waiting, and reading easily consumes minutes or even hours of human time. We are taking the most advanced computational engines ever built and using them like a magic 8-ball. Shaking the box and reading the text one result at a time severely limits the machine's true utility. In this workflow, the supercomputer isn't the constraint. The real bottleneck is the human sitting at the keyboard, waiting to process the next step. This diagram illustrates a property called stochasticity, the inherent statistical randomness built into large language models. Because of this randomness, feeding the exact same prompt into an AI 3 separate times yields 3 varying results. One might be a brilliant insight, while another is a total hallucination, an error where the AI confidently generates false information. Developers and casual users view this unpredictability as a bug. It makes the technology feel unreliable, like a tool that might break the moment you trust it with a critical task. But what if this chaotic bug is actually the exact mechanism we need to achieve hyper-accuracy? To see how, we have to stop treating AI as a solo actor and start treating it as a swarm. The shift begins by abandoning linear queries for massive parallel processing. Instead of one query, we spawn tens, hundreds, or even 1,000 independent sub-agents. Each of these AI instances tackles the same objective at the exact same moment. To make the swarm effective, we inject variations into the starting prompt. We might assign one agent as a harsh critic, another as a strict budget strategist, and a third as a visionary. By altering these starting conditions, we force the AI to attack the problem from every conceivable angle simultaneously, all without adding a single second of human waiting time. This circular graph represents a search space, the universe of every theoretical answer. A single prompt explores just a tiny sliver, but with a parallel swarm, hundreds of individual slivers light up instantly, mapping every hidden corner all at once. Volume solves the problem of narrow results. The swarm maps every possibility in the exact same time it takes a human to run one single query. This creates a massive flood of data. The challenge is no longer getting an answer, it's finding the accurate signal inside hundreds of generated responses. In stochastic multi-agent consensus, a central orchestrator mathematically calculates the swarm statistics, forming a bell curve. The dense center highlights the highly probable consensus answers. We also isolate the extreme edges, the 1% outliers representing dangerous hallucinations or absolute genius. To finalize the filter, the orchestrator forces agents with differing views into a shared chat room. Here, they debate their findings, challenge each other's logic, and expose any remaining blind spots. Pitting AIs against each other to debate and calculate probabilities automates the process of catching errors. It removes the need for human intervention to find the truth. Consider the scale of the automated workflow we just executed, analyzing 100 variations of a problem, hosting a peer-reviewed debate, and delivering a verified consensus report. Because the agents work in parallel, this entire process concludes in the time it takes a human to read a single Wikipedia page. This creates a massive economic arbitrage. We are trading literal pennies in API computing tokens, which are the digital units of currency used to pay for AI generation, for the equivalent of hundreds of hours of high-level human analysis. Moving beyond the pursuit of one perfect, all-knowing model reveals a more powerful strategy, the skillful orchestration of countless imperfect ones. By embracing statistical variance rather than fighting it, we turn the unpredictable chaos of machine probability into a highly accurate engine for innovation.